recognition under noisy environment, my current project. Now, there are many challenges faced by facial emotion recognition's ability to deal with complicated environment conditions such as noisy environments. Human facial expressions can be divided or classified into seven basic emotions: happy, sad, surprise, fear, anger, disgust, and neutral. This particular project aims to classify these seven emotions under noisy environments using empirical mode decomposition and support vector machines. A series of experiments are also conducted on concatenate database to recognize the emotion by minimizing the effect of noise. This is the particular database which gives us 1.55 GB of research data, which is only used to research on facial emotions. So we are going to use we have used that particular database to extract images and to detect or classify emotions using our SVM. Now, this is the particular process followed by us in this project. First, we have a noisy image, then we pass it on to face detection. Now, as we have a noisy image, it's a normal image with a background. We only want to detect the emotion of the face. So, first important thing which we need to do is detect the face in that particular image. We are doing that using Viola Jones in face detection process. Then we move on to radon transform. Radon transform basically extracts the features of a 2D image, converts it into a 1D signal by keeping the important features into that particular signal. Now moving from radon transform to EMT. This is where the important part happens. Empirical mode decomposition. This is used basically to reduce or to break our particular signal into small components, and from those components reducing the noise as much as possible. Then coming to PCA plus LDA, this is used to basically move from a high dimensional space of our signal to a low dimensional space, and then again converting back to a particular image, 1D signal to the 2D signal. Now we pass on this to our SVM, the classifier, an important step in our particular project. The SVM is basically trained to learn the emotions, the seven emotions which we discussed earlier in this particular project. Now we will discuss each and every part. Concatenate database. It is used for research in automatic facial image analysis and synthesis for perpetual studies. There are mainly three versions of this. The third version is not yet out, but we are using the second version of the concatenate database called as CK+. It includes both post and non-post expressions and additional types of metadata. This database is fully FACS coded, that is facial action coding system is used to code this particular dataset, which is actually used by us to detect which particular image is depicting which emotion. The selection criteria of us, like this is a huge database, so we have also selected only some part of the database to train our SVM. So the selection criteria of the experiment is as follows. We are using 266 images basically from 327 to 593 number in our database from the CK plus database. The sequence could be labeled as one of the six basic emotions from the metadata which we achieve from CK database. The subjects that contain 4 to 6 emotions per sequence are considered. The database comprises of 80 subjects that varies among ages 18 to 30 years, ethnicities from African American and Asian counties, and genders are male and female. This is an example of our concatenated database, and this is how the images look in our database with the background. As you can see, clean images but with a background, not only face. Coming to face detection, an important step. So the original face image is of size m cross n pixels. So basically it can be 649 by 429 or some of the images are 650 by 490 pixels, and which are cropped into 100 by 100 pixels. We have used various HAR cascades for detection of various face features using detect multi-scale functions. So HAR is basically a feature-based cascade classifier for object detection. Initially, the algorithm needs a lot of positive images and negative images to train the classifier to detect that particular face from an image. This HAR features is basically behaves like a convolution and detects facial features like given in the below image over here, which is edge features, the line features, the four rectangle features, and so on. It detects the whole face from this. Coming to radon transform. So basically a radon transform converts a particular 2D signal into a 1D signal with various frequency levels and maintaining the frequency by reducing the noise. So basically if a function f represents an unknown density, then the radon transform represents the projection of that data obtained as the output of a tomographic scan. We have used radon transform to project a 2D facial image into 1D signal that will be preserved by radon transform before applying the feature extraction technique. Coming to empirical mode decomposition. Now, once we get a signal from our radon transform step, we come to empirical mode decomposition. Using EMD, any complicated data set can be decomposed into finite and often small number of components. So basically our frequency which we get as a 1D signal from radon transform, it is cut into small number of pieces or small number of components by EMD. Now EMD adaptively decomposes any complicated signal into monocomponent functions, so-called intrinsic mode functions via sifting process. This particular technique enables to minimize the effect of noise in classifying the facial emotion. So whatever the noise which was incurred in our particular image, it is reduced by using EMD by following a set number of sifting process steps till a particular residue level. Now after this we move on to PCA plus LD. In this technique basically we any pattern recognition problem, the biggest problem is basically singularity of the input signal. The number of samples is much smaller than the number of features. This is a big problem for pattern recognition. So PCA plus LDA steps in over here. So and it basically converts our high dimensional space to a lower dimensional space, thus making our SW signal, the image signal, in no more singular. This can be done by mapping the PCA space of F large eigenvalues and then employing the LDA to reduce the dimension. Now moving on to the biggest step, classification. SVM, support vector machine. Support vector machine taking a given labeled training data, the algorithm outputs an optimal hyperplane which categorizes new examples. For example, considering a simple example of linearly separable 2D set of points and converting and classifying it into two classes as shown in the figure over here. Now we have to find a separating line over here, and there are many lines as you can see over here. But the operation of SVM algorithm is based on finding the hyperplane that gives the largest minimum distance to the training examples. This is the optimal hyperplane which is classified by the SVM algorithm. This is the use of SVM algorithm. So now this was just an example of 2D points. This is used basically to classify our image into the 7 basic emotions which we wanted to classify into. So this is what our SVM does, and it is trained on all that particular data of 266 images having 266 various features of neutral as well as the highest base emotion which we have captured. So 266 into 2 times images we have, and we are classifying them into various emotions which we have. There are various implementation steps which we have employed. First is the data setup for the process. Now we get the data set into subject-wise data set. So basically a subject is a particular user who is basically giving all the emotions, all the 7 emotions in various images which are captured for him. Our data setup process actually classifies them or segregates them into various emotion-based directory structures so that it is easy to actually perform a classification when we pass on the data towards our whole 6-step process. Coming from data setup process to face detection and sorting the data set. Now we have images with backgrounds. We only want the particular image with the face. So face detection technique, basically the Haar cascades which we discussed earlier, are used over here to take a particular image, classify it, crop it into the face of that particular image and store it into a separate data directory structure. That is what is done in face detection technique. Now our images from CK Plus database are very clean. It doesn't have noise, so there is no point on actually doing this experiment. But we have to do this experiment on the basis of a noise. So we add the noise purposefully by using a particular function of OpenCV called as random, which adds Gaussian noise to a particular image. So we have added Gaussian noise of various variances like 0.05, 0.1 and 0.15, and based on these we have classified the images by training data into these three Gaussian noise uh, images. Coming to implementation of radon transform. Now, as we discussed, radon transform converts our particular signal, 2D image signal, into 1D signal by preserving the features of that particular signal. That is what the radon transform does for us as well. Coming to applying of EMD and PCA plus LDA, this step does all these three things. So basically it does the sifting process of EMD to reduce the noise, then it moves to PCA plus LDA to uh, move from high dimensional space to lower dimensional space. Coming to SVM for classification, here is where the important part happens of learning the database, learning the data set of classifying images, where the images are classified. So SVM was actually trained to classify images. Each particular variance level of Gaussian's noise was trained for at least 150 epochs. There are 266 into 2 times images and 150 epochs of each particular Gaussian noise. So this is where the training happened, and the whole process was trained to classify images, any image, into the 7 basic emotions which we have. This is a live emotion detection system which we have created. So as you can see over here, the live system which we will see in a while, it detects the face, it detects the emotion of the face, it also shows what particular image is passed on to the process. So this is the grayscale image which is passed on to the process. Now coming to our demo. So let's have a demo of our system. So as you can see over here, it's detecting a particular emotion on my face. So it's neutral now, and here is the image, grayscale image, which it is passing through the whole process, and I'm showing anger. Yeah, so that's it. This is how it is detecting live facial emotion detection, and as you can see how fast it is. And as in SVM, basically we have used the Fisher face of OpenCV to detect the particular emotion of a particular face. So that is why it is very fast while predicting. So now starting with our code which we have written. So this is our dataset initializer. Here we are actually segregating our datasets according to each of the emotion which we have discussed in our previous slides, so that it is easy for us to classify them later. And this is basically extracting the face using the HAR cascades which we discussed earlier. Coming to EMD, so the most important step which we have used is empirical mode decomposition. So this is a function where we perform our sifting process up till a particular residue. Coming to our classifier, so in this we have done our rest of the procedures of using radon transform, using this step, calling our EMD, and then performing our SVM training, that is running the recognizer on our particular fish face recognizer which we are using over here, and we are storing the results called in a results.yml file, which is again used for the next iteration of the epoch. Now coming to plotting of graphs, so coming to live face recognition. So here is where the video was running in a while loop. So this is a while loop which we are running and following the whole procedure again, and which can actually detect our faces. So now coming to plotting of graphs, where we are actually comparing each particular graph plot which we are storing over there. So this is a plot graph. So this actually shows us that the average is around 80% of accuracy, and the similar is maintained for with Gaussian noise, but with a lower average of accuracy, which moves to 75, 74 and all that stuff, but does not go below 70% of accuracy. So using EMD, we have a lot amount of usage of EMD which we have done to reduce the increase the accuracy and reduce the error.